All right, so the one person I saw had a solution for this yesterday isn't here.
Nice.
So now I'm waiting for the next person who's gonna have a solution for this. Does anyone else have a solution for this yet?
I do, but.
Yeah? So before I got distracted last time, here's what I had. So I think this shouldn't take too long to finish off. So let's go ahead and even starting here, let's see if we can finish this off in the first 5 or 10 minutes of class. And then I have one more that we can move to that I think will have some good outcomes associated with it. So basically we're splitting the file by the comma, which doesn't include the comma. So what we're gonna have by the time we're done with this is a bunch of strings that have quotes at the start and at the end. So if we wanna figure out what letter is there, starting with the first letter of the name, we're gonna start with index 1 in each of these strings. We wanna say for each string, for each letter in the name, and we know that the string is gonna start and end with a double quote. At least I assume it is. If I look at, I guess it doesn't even have that here, does it? Are there any of these names that don't have double quotes around? That would be really unfortunate. Ooh, I see Zelda. Someone's a fan of good names. Everything is uppercase. Everything is comma separated, and I see quotes around everything. Here's what I, does this match anyone else who thinks they've solved it? We want to throw this in Project Euler for me and verify this is the right answer. We can do that too. We have verification. Can someone do that?
Go sign in. Yeah, I'm gonna walk in. I 19. Probably 0. 600.
Going to assume this is right since no one wants to verify this one.
I will.
I can at least explain my reasoning while this is happening. So we know we have a file. We know this file is on a single line. It's comma separated and each one of the names is surrounded by quotes. So my process for this was to make an array split by the comma. The way that split works is it throws away that character each time it sees it. So it's going to find quote the first name quote and store that in index 0 of this array. Quote the second name quote and store that in the first array, first index of the array. The next one, the next one, the next one, however many there happen to be. So then I set up a total, which is going to be the total value. So this is the right answer, I have verification. So the total is going to store the total so far. And the count is the current name that we are on. So we start with the first name. So it was telling me that what we need to do is we need to add, or we need to multiply the position times the value of the name, which is found by adding up the letter of the alphabet. A is 1, B is 2, C is 3, D is 4, etc. for each letter in their name. So we start with total being 0. I wanted to make sure that I wasn't doing integer wrapping, so I set it equal to a long. I verified that I got the same answer, so this can be an int because it is below the integer.max value. Then we want to go through and say for every name in our list of names, so we're going to do something for each name. What do we want to do? We want to set the sum of the value of that name equal to 0. Then we want to iterate character by character through that name. So we start at index 1, because we know index 0 is that double quote. And we want to go, well, less than name dot length minus 1, which ignores the last character in the name, which is the other double quote. So we know that the name starts and ends with double quotes. We don't want to count those as part of our solution. So what we need to do at that point is we need to add to something that represents the offset of that letter from A. So we know A has value 1. If we take the character's ASCII code, subtract the ASCII code for capital A, because we know in the ASCII table they're stored sequentially. B minus A is 1, C minus A is 2, C minus B is 1. We know they're stored sequentially in the ASCII table. So this expression, since characters are internally stored as integers, we can just take the value of the character at the ith position, which is some capital letter, subtract the value of capital A, and add 1, and that will get us the value of that character from the perspective of this problem. We do that for every character in the name. Then we add that to our running total that's keeping track of the total value of every name. We add that sum times the count that we were asked, so that for the first string, we multiply it by 1. For the second name, we multiply it by 2. For the third name, we multiply it by 3. That's what the problem was telling us to do. Add that to total, bump up count, loop back around to the next name, continue this process for every name in the file. And then when we're done, the final value is stored in the variable total. Does anyone have questions about this implementation and why it solves that problem?
Well, you have to like nest the new file inside the scanner.
It's just a way of doing it in one line rather than, you could do scanner S, or sorry, file F equals new file names.txt, scanner S equals new scanner F that points at that file. But since we never need the file object except to point a scanner at it, we don't need to store a name for this file object. We kind of just throw away to this file, we throw away the reference to this file object because we don't need it for anything. So this is how I've just become used to opening a file that we don't need anything from the file object, is to embed it inside the scanner. And I prefer a scanner to a file reader or a buffered reader, whatever other tools Java has. A scanner kind of just does it all, and it's cleaner. Questions? All right, let's look at another problem. I want to do number spiral diagonals, problem number 28. So starting with the number 1, moving to the right in a clockwise direction. In a 5 by 5 spiral, we see we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, etc., all the way to 25. And that's what's needed to complete that 5 by 5 spiral. The sum on the diagonals is 101. So the problem asks, now imagine that we extended this logic all the way until we had a spiral that was 1001 by 1001. What would the sum of the diagonal numbers be in the spiral that is 1001 by 1001 numbers long? So let people think about and dissect that and think about, is there an easy way to calculate this? Because obviously we don't really want to visualize this spiral as we're doing it. So is there some way to break this spiral down into some math or some logic?
So if we are gonna start with number 1, we're gonna go all the way to number 25, right? And then these are 1, 2, 3, 4, 5, all the way to 25.
Right.
So if we divide them by 2 and then add 1 to 24, 2 to 23, all the way. So that way we get the total.
Maybe. You think that will generalize to a 1001 by 1001 spiral? I'm not saying you're wrong. I'm just posing the question back at you that, will that generalize? I picked this question because it's really good for pattern recognition. Try to break this down into its associated patterns. And try to come up with the underlying math or the underlying logic that creates that pattern. But I think we can do this with a much simpler program than it might first seem. But take some time to think about it. Try to find the patterns embedded in this. See if you can find a generalized philosophy for how we're going to get an answer.
So, like, in this example, we are going from 1 to 25. If you put like a row 1 to 25, 0 to 25, probably I'm going the wrong direction. 1 to 25, and then 25 to 0 on the next one,
Okay.
and then add them together. So we get like 26 times
26,
25.
26, 26, yeah.
So why we, like, if we multiply 25 by 26 directly?
So we only care about the numbers that are on the diagonals. We only care about the numbers that are in red here. We want to find the sum of everything on the diagonals. Everything else that's in black, we're just gonna ignore. I agree that if we were just trying to find the sum of 1 to 25, then it would just be 25 times 26 divided by 2. We only care about the numbers on the diagonals.
I think we did similar thing, but we moved like 3 different directions, and this one you are moving one direction. Like move to the right, and then down, one down, right, one down, all the way to the end.
Interesting, so. How are we gonna recognize the patterns that are in here? How would you turn that concept into a program?
So we'll start with the top left corner, 21, start with that, and
How do you
then,
know it's 21?
like, whatever that number is.
How are you gonna calculate that? If we have a 1001 by 1001 spiral, what's the top left corner?
Like, start from 1, it's adding 2 every time it moves to the next number.
Plus 2, plus 2, plus 2,
Like
plus 2.
1 plus 2, and then 3 plus 2, and then 5 plus 2 to the next number, and 7 plus 2 to the next number. It is adding like 2 each time you get to the next number.
I like that. That's a good observation. Does that continue after 9? I think that's an important observation, though. That's something that you should latch onto as part of something that might be part of the solution. It doesn't continue after 9, but that does not mean that that logic should just be thrown away.
It looks like it stops after the corners.
And then it adds 4, it doubles the number.
Interesting. So we go from adding 2 to adding 4, adding 4, adding 4, adding 4.
And then next round, probably double that number, multiply, probably like.
Interesting.
3 times 2, and then,
That's an interesting idea. Play around with it, see if that works.
So what you got, 8? That's
You could play around with that. Where should the next corner be? What should the next corner be? So the next corner, as we move around, should be down here. After the 25. And we have plus 4, plus 4, plus 4, plus 4. So the next number should be here, 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 here. Was that 8?
I was just going based off his logic.
Yeah.
4.
Finding some pattern. There is some pattern there. It's not multiplying it by 2, but there is a pattern.
like the other pattern would be, if we start with 21, this way it goes up. If we go down, it goes down. So 21, 20, 19. And then to the right, on the very bottom row, it goes down also. So. Now, if you're counting that, yeah. So we'll start with the center one, and then on the next, to the right, we will count the number. Like we will start with that one, and then we move to the right, then we will leave 1 and count the other one. On the next one, we will leave 3 and count the third one, fourth one.
Do that here for 4. 4, 4, 4.
right, and then the next one we will leave 4 and then count the top and bottom one.
Interesting.
So as we go inside, we will start with 1, and we go outside, we will leave 1 and count the other top, and then we leave 3 and then count the top, and then leave 4 and count the top and bottom.
What would that pattern look like? How would you code that? I ask the hard questions. So my logic for this is gonna be, let's start with this 1. And we know that we need to add 2 to get to the next. We add 2 to get to the next, we add 2 to get to the next, we add 2 to get to the next. Eventually this changes and we need to add 4 to get to the next, 4 to get to the next, 4 to get to the next, 4 to get to the next. How do we continue from there? And also, when do we stop? Yeah,
I think that, we add 6 next.
add 6 next.
And we probably add 8 after that. Like after 4.
Let's play around with it. I think you're absolutely right. So 25, 6, 7, 8, 9, 30, 31. It's going to be 1, 2, 3, 4, 5, 6 to the next one. Then 32, 33, 34, 35, 36, 37. 38, 39, 40, 41, 42, 43. 44, 45, 46, 47, 48, 49. To get to the next diagonals, these are each 6 apart. That seems to flow logically. To get to the next one, since this is already, I should draw this 49 right here. We need to go 1, 2, 3, 4, 5, 6, 7, 8, down to get to the next thing in the diagonal. This seems like it's going to scale, and if you want to understand the why behind it, let's say we have a square, and we have a square inside of that that is of size, that size -1. Think about the difference in the areas of those things. And the difference in the side lengths. If you're trying to isolate where each of these are, what is the associated side length compared to the entire side length of the one before it? You can start to again envision this as a fractal of a square inside of a square inside of a square. It looks like each time around, each row and column is 2 more than the last one, which tells us to get from one corner to the next, we need to go 2 more than the last time we did it for a square of size, whatever the size is minus 1. What's the final number in a 1001 by 1001 spiral? We should be able to calculate that pretty easily. What expression gets us the final number in a 1001 by 1001 spiral? Yeah?
Side squared.
Yeah. We know that this value is 5 squared because we have a square that is 5 by 5. A square that is 5 width by 5 height is going to be 5 times 5 equals 25. That's the last number that's going to be in the spiral. It's the square of the side length. So a 1001 by 1001 spiral, the final number is going to be 1001 squared. So that tells us if we continue this process of adding 2, 2, 2, 2, 4, 4, 4, 4, 6, 6, 6, 6, 8, 8, 8, 8, etc., we want to stop when the value of that is greater than 1001 squared. I think we have enough now to implement it. Let's crank it out.
6. Just solve it. Do you understand a lot? No. Sure.
I think this does.
Yeah, but it's,
But it's all right.
so,
Yeah, I see the issue.
so you're not even thinking that. Big one.
But- Once you hit 1,000.
No, no, no. That's. Okay, so, but then.
It matters what this gets to.
No, no, but how many times doing? It's not, but then it's gonna add two, you need to add 4, so how do you do it? It's not adding 2.
Use it's one of the-
What do you mean?
So what
Oh, because
each,
it's 3 times 3. And then 5 times 5 is,
because in that case, the 5.5, you stop at 45. So you stop at
so,
square root.
If you stop at the screen. So then.
What do you get if you use the size of Much is what? Total sister.
Also, was the curve. Very less than equals to.
Yeah.
Okay.
Yeah, so you would want to stop that last revolution. You won't want to do the next revolution when it's equal to. I was thinking we want to still calculate it when it's equal to, but not start a new revolution of 4 when it's equal to, so it should be less than. So
It's-
now,
Still not.
no, if I change this to 1001,
It should, yeah.
this should work. Is that what you got? That one's better.
That's the one.
Anyone have questions on the logic?
Why do we have to start at 1 for the total?
Because 1 is not part of a revolution. If we go back to the image here, we add 2, starting at 1 4 times. So we want to +2, +2, +2, +2 from 1. We don't want to start with 1 as the first thing that we do. Adding 1 should be where we have started. We started by adding 1. I made that mistake too. Anyone with questions on the implementation? Other questions? How is the project going for people? You should be starting your implementation. You should have the design figured out, hopefully, and be starting the implementation. So my recommendation for people between today and tomorrow, in addition to making progress on the current lab, try to get to a point where you are implementing and have implementation related questions, and that way I can answer them in class tomorrow.
And that project's due on the last day of class, right?
Yeah. Said there is a lot to this project. I am very much challenging what you are currently capable of with this project. But I think that by communicating between you and me as you go through this process, we can get it there. And I think that will be very good for you moving into software engineering to have this under your belt.
What day's the final on?
I think it's Monday. I think it's the very first day of finals.
Ugh,
I remember looking that up and I remember that being the conclusion. I do not trust my own memory. You should verify that.
Is it your decision?
No, it's depending on the class start time. So every class that meets on Monday, you look at the Monday's start time. So all classes that are Monday 12 o'clock classes have a final slot. If it were my choice, I could ask the student I hated the most, when is your most difficult final? And I'd make it right then. I should not have that kind of power. All right, we're basically out of time. I think we did today what I was hoping to, a couple of problems, seeing some pattern recognition, taking that pattern recognition, turning it into code, seeing that even I don't always get it right on the first stab. That happens.
At least it was just a little tweaks.
Yeah. It's just using logic and iterating on the logic, figuring out why is my logic wrong and figuring out why your logic is wrong and turning it into logic that is right. Tomorrow we'll have one more day of this, and the reason is that I'd like to give you a survey soon about some of what we're going to be covering over the next couple of weeks. You will be my guinea pigs for a little bit. What are we here for? Tomorrow for that.